Hello and welcome back. I'm Constantine and today I've got great news for you. At the end of this video, you'll be able to break in any place you want. And why is that, you might wonder? Because you're about to fully understand how to create an algorithm to open any lock in the world. Or I might exaggerate a little bit, but I think it's still very valuable to fully understand this kind of problem and the patterns that are used because there are so many problems in coding interviews which use the same pattern. And just before we're getting into solving this wonderful problem, I'd like to ask you if you feel you get any value from any of these videos that I'm making. And as I am a work in progress myself, any form of feedback is highly appreciated. Because I've only created this channel for a simple reason. I want to manifest my passion for teaching, and this is my way of giving back. So if you fully understand, if you think you're getting any value, any constructive feedback is highly welcomed and appreciated. Now let's go ahead and solve this beautiful problem. We're asked to open a lock. What a cool problem, right? So we're given a lock and we're having a lock in front of you with four circular wheels, and each of them go from 0 to 9. If you have probably went to in the locker rooms in the gym, you'll find these locks, right? And the wheels can rotate freely and wrap around. We could turn 9 into 0 and 0 into 9. Depends on which way we're going, like upwards or downwards. And the lock initially, let's say when you buy from the store, it starts at 000. And we are given a list of dead ends. So this problem, they want to make this problem a little harder. We're given a list of dead ends and we need to make it to our target. And we can see in the constraints that target will never be in dead ends, and target and dead ends consists of digits only. So let's go ahead and try to visualize this problem a bit before even try to attempting solving this problem. So this is our lock, and this starts at 0 0. We got it from the store and starts from 0 0, and we know we could go at each one of these little wheels. We could go upwards, and if we do upwards, this will become 1, or if we do downwards, this will become 9, right? There's only two possible combinations, and we need to go to 0 2 0 2. That's our combination. Not too complicated combination, but that's what we chose, right? So one might say, why don't we just do rotate this little element right here twice? So we're gonna get to 1, and then we're gonna get to 2, and then we keep this to a 0, we keep this to a 0, and then we're gonna rotate this twice, right? But once we're rotating it once to the right, what surprise do we have? This is in the dead ends. So we can do that. It's right here. So we can do that, right? So obviously this is not that simple of a problem, because if we would have no dead ends, it would be much more simpler. So let's think about how are we gonna implement this problem? Like, what's our intuition? What do we have in this problem? What key elements or keywords we have in this problem that we could use in order to think about even a pattern at first? Because when I firstly saw this problem, I had no idea. But then by looking at this 0 0 0, so we have a starting point and we need to go to 0 2 0 2, and we have a series of obstacles right here, right? All these dead ends are right here, are obstacles. So what do you see? We have a starting point, we have a destination, and we have something that we need to go from the starting to the destination. So usually when you see this pattern, you have a starting point and a destination point, and you have some obstacles or something like that. Usually this is a very good indication that the pattern that you have to think about, it's a breadth first search. Why? Because breadth first search is usually, for example, if you have a matrix and you have one point and you need to go to another point, a breadth first search could be a good indication just because you would go level by level, right? And especially if you need to avoid some obstacles. So I think this is a very good candidate for a breadth first search. So if we decided that we're gonna try to implement the solution of this problem with the breadth first search, then what else is needed, right? Now the logic comes in. So a breadth first search first is gonna have a queue, right? So if you imagine this problem as a tree, you always add the root to your queue in a breadth first search. So this is our root technically right now, because we're starting, they give us the starting point. So we're gonna add 0, 0, 0 as a root in our queue, as a string. And then we also need to check if we made it to one of these dead ends, because if we made it to the dead end, then we can't go further, so we need to go back. So this is given to us in a string array. So in order to have a faster lookup, we could just create a set with these elements. So we're gonna have a set where we're gonna call it dead, right? And this is going to be a set. And this will contain exactly all these elements from here. Good. So now what else do we need? Let me ask you this. If we made it to this point, 0, 0, 0, you made it once. Do you want to ever recheck this combination again? Probably not, right? Because if this is not a valid combination, then you know you can't use it again. So we need to add another set, which we'll call it visited. And this visited basically will contain all the elements that we have tried, all the combinations that we have tried. So in this case, since we're starting from 0, 0, 0, we're also gonna add this combination to our visited set. So good, now we have this. Now we have a classic breadth first search problem, right? We're adding this to our queue, so we know in a breadth first search problem, then we're pulling out of our queue, and this is our string that we have right now. So we need to do two checks right here. First check is to see if this string is a dead end. If it's a dead end, we'll just continue because we can't use this string, correct? But what if this string is not a dead end, but what if it's right our target? What if our combination here would have been 0, 0, 0? Let's say an easy combination, but a lot of people do it, right? So what if that's the case? Then all we have to do now is just return the number of steps that we took to make it to the target, which in this case would be 0, right? Or how many, like if it would be 0, 0, 0, 1, then we took one step, right? So we'll just return 1. And if none of these two checks are true, then we need to think about our core part of the algorithm, right? So we know we have 4 possible combinations right here, 4 possible numbers that we can play with. So we know that one of these numbers could go upwards or downwards. So for any case, for example, let's say we want to try this number. What can we try with this number? So we could spin this little wheel upwards, and then we would have this 0, 0, 1, 0, or we could spin it downwards and we would have 0, 0, 9, and 0, correct? So these are the two only possible scenarios when we are deciding to spin this wheel from this position. And the same thing we could do for any of those. So since we have 4 possible, 4 wheels, we'll have a for loop, and our for loop will start from 0, and then it will go up to 3, right, inclusive. And then we'll get the element where we are right now. Let's say we're at this element, and how from this position, how we'll get to these 2 possibilities. So you see, we need to preserve everything that we have from the beginning all the way until this element. So we're getting these 2 zeros. We're gonna decide to spin this element upwards or downwards, which is in this case upwards is 1, and then we're preserving everything that's after the element. And then we're doing exactly the same thing for every single element. And once we've done that, we are going to check to see if the next possible combination, the one of these 2 are in the dead ends. And if they're not in the dead ends, and they're also not in the visited set, because if we've not seen them before, then we're gonna go ahead and add it to our queue. So this is basically the main core part of our algorithm. So now let's go to Leetcode super quick, and let's try to code this problem very quickly. So we said we have a few things to declare at first, right? So we know that we need a set which will contain our dead ends, right? Right now they're given to us in a string array. So let's do a string set and let's call it dead set, and will be equal to new hash set. Cool. And then let's actually even go ahead and add all these elements. So we'll do for string s in our dead ends. We'll just add it to our set. Cool. Now we said we need a visited set, right? So we'll do a set, which again will have strings, and we'll call it visited equal to new hash set. And then we said since we're doing a BFS, we're gonna need a queue as well, which will also contain strings, right? And we'll call it queue simple new array dequeue. Cool. So now we said we are going to add the first element, the root, the starting point, or however we want to call it. We're going to add it into our visited and into our queue. So we're going to add it into our queue. And we're also going to add it into our visited set. So we make sure we're not going to visit this combination again. And we'll also have a variable. I'll call it steps. You could call it result or anything. This is basically how many steps we'll be taking, and this is what we'll return at the end. So right now, while our queue is not empty, so right now is not empty, right? Because we just added 0, 0, 0, right? So we added the first element. So right now we have some processing to do here, right? So while our queue is not empty, we'll get the size of the queue. And once we got the size of the queue, we need to do some processing through all the elements that we have in our queue right now. So while size minus minus is greater than 0, right now we need to pull whatever we have in our queue. So we'll create another string, which we'll call it current, and this will be equal to queue.pull. And we said we need to do these two checks right now, right? We said we need to check if it's in the dead end or if we already made it to target. So let's go ahead and write this super quickly. So if dead contains cur, so if this is in our set, we'll just continue. We'll just simply keep going. Or if our current equals our target, and the way we're doing equals is because this is how we do comparison in Java, of comparison of two strings. We'll just return our number of steps we've taken to make it to this point. Cool. Now we said we need to do our main part of the algorithm, right? So we're going to declare a string builder, and we're going to call it simply SB. And we're going to pass our current string. And then we said we will do a for loop. So we'll have I start at 0, go up to 4. And we'll get the element right now. We'll get this element where we are. Let's say we're right here. We're getting this element because we need to do some processing. We need to shift only that element. So we're getting this element, and it's going to be SB char at I. And now let's create these two strings. We'll call this upwards because we'll shift it upwards, and we'll create this downwards. So let's create these two strings right now. String upwards. So this is going to be everything before our element where we currently are, right? So it'll be SB substring from 0 until I, plus we have some processing to do here, and then plus everything that we have after that element. So after SB substring from I plus 1, right? So this is what we have before, this is what we have after the element, and right now we need to rotate this little wheel upwards or downwards. And how are we going to do that? So we could check if there's two scenarios. What if it's 9? What if this right here is 9? We said if it's 9, we need to make it to 0 just because that's the next element. Or if it's 0 and we're going backwards, we'll make it 9. So we'll check if this char is equal to 9. If that's the case, we will make it 0. Otherwise, we'll get the value of that char, the numeric value of that char, and then we'll add 1. I think I said jar instead of char. And then we'll do exactly the same thing for our downwards string. So our downwards string is going to be equal to substring. So whatever we have before and whatever we have after. And then right now we need to check if this element is 0, we said, we're going to make it a 9. Otherwise, we're going to go the value minus 1. So for example, if we have 3, it's not a 0, right? So we're going to make it from a 3, we're going to make it a 2. We're going to rotate it to the bottom, basically. Okay, so after we've done these two things, we could add these two strings into our queue. But we said we don't want to add them if they're in the dead ends, or we don't want to add them if we've seen them before. So we could probably just do a simple check if our dead is not contains our upwards, and if visited also does not contain our string, then we'll go ahead and then we'll add it into oops, I think I'm missing a parenthesis right here, and think I've added an extra one right here, and then we'll go ahead and we'll add it into our queue. And we said if we've seen 0, 0, 0, we don't want to look at that combination again, so we'll also add it into our visited set. Visited, add upwards. Cool. And then we'll do exactly the same thing for downwards as well, because if that's a possible string, if that's a good candidate, we need to add that one too. And we'll just replace this upwards with downwards. And after we made it to this point, all we have to do now is, after this iteration of the loop, so right now we're processing everything that we have at that current level, all we have to do is steps plus plus. So right now we are basically incrementing our steps. If it's not in that level, then it means that it's one step further. And if we couldn't make it to this line ever, then it means we couldn't get to our target. So all we have to do is return -1 as it's stated here in the description of the problem. And I think that should be it for this problem. Let's give it a try. Yeah, so it's been accepted. I think that's it for this problem. And look at that, right now you are one step closer to crack any coding interview out there. Thank you for watching, and if you feel you understood my way of explaining things, a like would be highly appreciated, just because it helps with the algorithm and it makes me feel that the effort I put into making these videos is so worth it. Thank you, and see you in the next video.